There's this secret engine running behind the scenes of so much of the AI we use every day. It's one of the most important pieces of the puzzle, but most people have never even heard of it. Today, we're pulling back the curtain on that secret engine, vector indexing. Have you ever really thought about that? You type in something like a rainy day coffee shop vibe or an intense gym workout track. How on earth does a computer understand a vibe? That's a huge challenge, right? Computers are built for cold, hard facts, not abstract feelings. The answer, it turns out, is all about organization. So here's how we're going to tackle this. First, we'll look at the massive data problem that started it all. Then we'll get into what vector indexing actually is. We'll peek under the hood to see how it works, talk about the really important trade-off between being fast and being perfect, and finally, we'll see exactly how this is the tech powering the AI all around us. Okay, let's dive right in. Before we can really appreciate the solution, we have to understand just how big the problem is. We are absolutely swimming in a massive, messy sea of data. Think about how a normal database works. It's fantastic if you're looking for an exact match, a specific name, a product ID, you name it. But what happens when you want to search for an idea? How do you ask a database to find a picture that feels happy or a document that has a similar meaning to another one, even if they don't share any of the same keywords? That's where the old ways just completely break down. So this kind of lays out our two basic options. On the one hand, you have the brute force method. This is like trying to find one idea by reading every single book in a library, page by page. Yeah, you'll find it eventually and it'll be a perfect match, but it would take forever. The other option? An indexed search. It's like using the library's card catalog to go straight to the right shelf. It's smarter, it's strategic, and most importantly, it's fast. And that brings us to the solution. If all our data is this giant, chaotic library, then you can think of vector indexing as our own personal AI librarian who's already gone through and organized everything for us perfectly. So here's the official definition. I know it sounds a little dense and technical, but the idea behind it is actually pretty simple. You see, AI can turn pretty much anything, a song, a picture, a sentence, into a long list of numbers called a vector. And that vector captures the essence of the thing. So vector indexing is just a really clever map that organizes all those vectors so we can find ones that are similar in the blink of an eye. I love this analogy. It just makes the whole thing click. A regular phone book is great if you already know the name of the person you're looking for. A vector indexed is like a phone book for concepts. You can look up the idea of a sad acoustic song, and the index will immediately point you to all the songs whose numbers are conceptually close to that idea. And the benefits here are just, well, they're game changers. We're talking about searches that are blazing fast. This is what lets AI systems scale up to handle billions of items without breaking a sweat. It's way more efficient, and it's what makes all those real-time, instant AI applications actually possible. So, how does this magical organization really happen? How does the index get built? Let's peel back the layers just a little bit. Don't worry, we're going to keep this super straightforward. We can use a really popular method to see how this works. It's called the inverted file index, or IVF. Honestly, the best way to picture this is to think about how you'd organize a bookstore. You wouldn't just toss all the books into one giant pile, right? No, you'd group them into sections. Sci-fi over here, history over there, and so on. The IVF process basically does that in 3 steps. First, the algorithm automatically groups all the similar vectors together into what it calls clusters. These are your genres. Next, it builds an index. That's the map that says, hey, these vectors are in this cluster and those vectors are in that one. And then step 3 is the search. When you look for something, the system is smart enough to only check the 1 or 2 most relevant clusters, completely ignoring the rest. And that, ignoring almost everything, is the secret sauce that makes it so unbelievably fast. But, and there's always a but, this incredible speed doesn't come for free. It involves a very important, very strategic compromise. It's a trade-off. And this is a really crucial point. Because we're only looking in the most likely clusters, there's a tiny, tiny chance we might miss the single most perfect match if it just happens to be sitting on the edge of a different cluster we didn't check. We're trading a little sliver of perfect accuracy for a huge gain in speed. This whole technique is called approximate nearest neighbor search, or ANN. The choice really comes down to what you see here. If you need speed for a real-time app, you accept a good enough approximate result. The search is instant, and it doesn't hog resources. But if you're doing, say, scientific research and you absolutely need the perfect result, you can choose accuracy.
You'll just have to pay for it with more time and way more computing power. For pretty much 99% of the apps we use, good enough is way more than good enough.
Okay, so let's tie this all together. Let's see how this one core technology makes the leap from being a cool theory to being the foundation for the AI tools you probably use every single day.
I mean, its impact is just massive. It's the absolute backbone of recommendation engines that suggest what movie to watch next. It's what lets you drag an image into a search bar and say, "Find me more like this." It's totally fundamental to how modern chatbots understand what you're asking. And it's even used to spot weird patterns for things like fraud detection. And to make it even more real for you, those product suggestions you get on shopping sites, that's vector indexing. That search by image feature, that's vector indexing. Those super smart chatbots that can pull in current info using a technique called RAG, yep, that's vector indexing too. Even plagiarism checkers rely on it. All of them need this to work. This quote just nails it. It really gets to the core of what's happening here. Vector indexing isn't just a faster way to file things. It's a huge shift from simply finding data to actually understanding the meaning and the hidden connections within that data. So, if you remember one thing from all this, let it be this. Vector indexing is the magic wand that takes all the chaotic, messy data of our world, our pictures, our music, our words, and organizes it into a universe we can actually search for meaning. This ability is just so incredibly powerful. Right now, we use it to find a song or recommend a product. But as this tech gets even smarter and faster, it opens up this amazing question for the future. Now that we have a tool that can find meaning in almost any kind of data, what are we going to ask it to find next?